1 mole of cryptophycin, all right, reacts completely with sodium hydroxide, which will give the number of moles of sodium hydroxide required and the number of moles of alpha amino acid. So I guess sodium hydroxide can react, can act as a base as well as a base to hydrolyze the ester and the amides if there are any. So let me just break all the esters and amides so to see how many moles of sodium hydroxide is needed. 1 mole because it hydrolyzes ester, hydrolyzes ester, hydrolyze this ester, hydrolyzes amide, hydrolyzes amide. Okay, and actually it's kind of tricky. So 1 2 3 4 5 size sodium hydroxide is really needed, but actually this one can undergo nucleophilic substitution. The Cl can be kicked out, replaced with OH, so actually you need 6. So it's either B or D. All right, 6. Right, so let's show how many alpha amino acid products will be formed. So this is a bit tricky. So you must look out for alpha amino acid. It's called alpha amino acid, right? Alpha amino acid. Okay, alpha amino acid looks like this. So NH2, CH, R, C double bond O, OH. Okay? So alpha amino acid, so alpha amino acid, right? It must only have a carbon. This is called alpha carbon. There's only one carbon between the COH and the NH2. So and of course you have the R group. So I hope I'm going to just show you where they are. So hydrolyze, okay, and let me see here. Hydrolyze. Okay, I'm going to hydrolyze all of them, but I guess it is hopefully you can see where the amino acid. I'm going to circle because it's not so easy to show you, but this is the first amino acid. All right, so there's a carbon in between the NH and the C double bond O, so this is 1. Okay, some of you might be thinking, how about this one here? Okay, maybe show you the other one first. This is the other amino acid, the alpha amino acid is over here. Okay, so 2 already. Okay, some of you might have this, so this question is a bit tricky because they drew this one here. Okay, how about this one here? So how about this amino acid? Actually, this is C double bond O. Okay, if you say you hydrolyze it, right? So I'm just going to draw like that first. Okay, notice this is CH3 over here and a H, and this is a CHH, and last part is NH2. So if you notice, I would say this carbon here is the alpha carbon, but there's actually another carbon between them, all right, between the COH and NH2, and this is called the beta carbon. This is known as a beta amino acid. Okay, there are 2 carbon between the COH and NH2. So the one that's highlighted in red is actually a beta amino acid, so it's not considered. All right, so that's why the answer is actually B. Right, answer is actually B. There's only 2 alpha amino acid.